Hi students, welcome to physics classes. Today we will discuss about relation between angle of incidence and angle of refraction while light ray traveling from rarer medium to denser medium. When light ray traveling from rarer medium to denser medium, the relation between angle of incidence and angle of refraction. Relation between angle of incidence and angle of refraction we will discuss today. For that, first we should take pro circle. What is meant by pro circle? Pro circle means it is like a protractor but a small difference. We will discuss about how to prepare pro circle. How to prepare pro circle. We should take a plank, on that we should place the paper white chart like this, and we should draw one vertical line and one horizontal line. They are passing through point O. Intersection point is O. This horizontal line we can name as MM. Vertical line is NN. Now we should take the protractor and place along N and N. Place along N and O should be the center. So here starts with 0 up to 90 we should mark. And this side also starting with 0 up to 90 we should mark. Opposite side also starting with 0, 90 we should mark. Starting with 0, 90 we should mark. 0 means NN, 90 means MM. Okay, so here starting from 0 to 90 like this, 0 to 90 and 0 to 90, 0 to 90. Like this we should prepare pro circle. We should prepare pro circle like this. Now we should take semicircular glass disc. We should take semicircular glass disc. Semicircular glass disc. And we should place that semicircular glass disc on the pro circle. Before placing it, we should remember one thing. This MM will act as a interface and NN is acts as a normal. So semicircular pro circle that we should place on the pro circle. Semicircular glass disc that we should place on the pro circle like this. Now this diameter of the glass disc should coincide with MM and center with O. Diameter of the glass disc, semicircular glass disc, should be placed on the pro circle and the diameter should be coincides with MM, center with O. Like this we should place. Now this the glass disc is a denser medium. This is rarer medium. Glass disc is a denser medium. It is rarer medium. Now we should take laser light. We should take laser light. We should point along the normal NN. We should send the laser light along the normal NN and should pass through O. It should pass through O. Like this we should send. Now, while it is entering rarer to denser, it is passing along the normal. It is passing along the normal. That we should catch that light here. We should identify the light here. If we are unable to see, we should place a black chart here. Then we can see the light. Now, we know that light traveling along the normal will enter into denser medium without any deviation. There is no deviation when light ray traveling from rarer to denser or denser to rarer. When it is passing along the normal, no deviation. When light ray passing along the normal, light passes along normal through point O. Here, along normal, there is no deviation. No deviation, no change in its path. Now, we should send the light ray. I'll draw with another color. We should send the light ray by making 15 degrees with the normal. We should send the incident ray by making 15 degrees with the normal. Then angle of incidence equal to 15 degrees. Now light ray will enter into the denser medium. We know what will be happen here. Now that will come out of the glass disc. That we should find. Angle of refraction we should find by using a pro circle which is placed under the glass disc. We should find the angle of refraction. Once again I will repeat what I did. First we send light ray along the normal from rarer to denser. We found there is no deviation. It passes along the normal. Next we send the incident ray by making 15 degrees with the normal. By making 15 degrees with the normal. And we find the angle of refraction. Refracted ray we found and angle of refraction. That we should write in the table. Angle of refraction. Table will be like this. Angle of incidence, angle of refraction. Step by step we are discussing. No remaining terms I will tell you. Angle of incidence. Here what we taken and angle of refraction what we found. That we should write here. Next, repeat the same procedure as we discussed here. Send the light ray along through point O by making 15 degrees with the normal and find the angle of refraction, corresponding angle of refraction, and write it in the table. Now repeat the same procedure for 20 degrees, 30 degrees, 40 degrees, 50 degrees and 60 degrees as your wish. Find all corresponding angle of refractions. Find all corresponding angle of refraction and note down in the table. Note down in the table. Okay, now here we are mentioned that note down in the table. That's all. We should not write anything in the table. We should draw empty table because we are not doing experiment in the exam hall. We are not doing experiment. We are writing experimental procedure. Not doing experiment. So for all angle of incidences, we should find the corresponding angle of refraction. We should write in the table. Next, find sine angle of incidence. For this angle of incidence, sine we should find sine 15, sine 20, sine 30, sine 40, sine 50, sine 60. We should find and we should write in the table. Find sine angle of incidence and sine angle of refraction for all given values. And finally, find sin I by sin R. Sin I by sin R. So after finding sin I and sin R, if we do the ratio, it will be constant. It will be constant. What we found? Sin I by sin R equal to constant. Sin I by sin R equal to constant. This constant is equal to refractive index. Sin I by sin R equal to refractive index. Sin I by sin R equal to refractive index. Now here we took semicircular glass disc. So here we found refractive index by taking sin I by sin R, that constant value is equal to refractive index of glass. Refractive index of glass, that is equal to refractive index of glass. So we can write sin I by sin R equal to refractive index. Sin I by sin R equal to refractive index. Refractive index is denoted by letter N. We can denote like sin I by sin R equal to N, constant. Now here, by finding the angle of incidence and angle of refraction, by seeing the table angle of incidence and angle of refraction, we can say one thing. These all values, after finding all values, angle of incidence and angle of refraction, by seeing that, we can say angle of refraction is always less than angle of incidence. Angle of refraction is less than angle of incidence. Angle of refraction is less than angle of incidence for all values. So when light ray traveling from rarer medium to denser, when light ray traveling from rarer medium to denser medium, angle of refraction is less than angle of incidence. Okay, now here one thing we should remember. In the exam point of view, sometimes they are asking directly the question, what is the relation between angle of incidence and angle of refraction? So we can identify easily. Sometimes they are asking, write an activity to show that sin I by sin R equal to constant. Also we can identify sin I by sin R equal to constant. And sometimes they are asking, write an activity to show that angle of refraction is greater than angle of incidence. Angle of refraction is less than angle of incidence, or angle of incidence is greater than angle of refraction. Write an activity to show angle of incidence is greater than angle of refraction, or angle of refraction is less than angle of incidence when light ray traveling from rarer medium to denser medium. Rarer medium to denser medium. Like that they will ask the question. Whatever the question they asked, either directly given relation between angle of incidence and angle of refraction, or sin I by sin R equal to constant, or write an activity to show that angle of incidence is greater than angle of refraction, or angle of refraction is less than angle of incidence when light ray traveling from rarer medium to denser medium, we are able to write. Okay, and sometimes they are asking, write an activity to show Snell's law. From this sin I by sin R, we got refractive index of glass. Glass is a second medium with respect to air. Refractive index of glass. Here light ray traveling from air, refractive index N1, refractive index of N2. lighter traveling from air, refractive index of n1, glass refractive index n2. First medium refractive index n1, second medium refractive index n2. So here we find the refractive index of second medium with respect to first medium. So we can write sin I by sin r equal to n2 by n1. n21 means n2 by n1. So cross multiplication, n1 sin I equal to n2 sin r. This is Snell's law. This is Snell's law. Like this also we can conclude if they ask Snell's law. I hope it is very clear. Thank you for watching. Please subscribe.